yellow, sometimes white. We look around, probably
yellow and red.
right. Yeah, yes, so he's got a yellow and red one. But that's called calcium carbonate, which is a cement that you put all that together. Now here's one, this is a good sample somebody can have that we talked about a little earlier. Here's the white silica, pure silica, and here's the red. All of it was white originally, okay? And it just grew right out of the flood waters, but the bacteria is what created this red. And in the book, we actually have a page under the sand mark. So when you look under the Universal Flood chapter, there's 13 marks. One of them is called the sand mark. And in the sand mark, I have some sand that I got from the beach down in Mexico. And I took that sand and I put it in a jar. It was wet, and I sealed it. And I put it in a cabinet that didn't see any light for a couple months. And guess what happened inside that jar? The microbes in there ended up, some of them died, and other microbes ate their byproducts, their waste products. And you'll see black areas in there that are swirly, like these areas. Right on the page next to it, we took some soft sand, and we actually took that sand and we put it in a little pipe, little piece of a pipe cut this long, and we put a little screen on the top and bottom of the pipe so the sand would stay inside the pipe. I wanted to make sandstone. And I knew I couldn't just throw sand inside the reactor because it's a pipe like this and it would all settle to the bottom. And down at the bottom is hotter, 50 degrees hotter than it is up at the top, right? And I knew it was just all melted. So how would I remember there's this convection current going on inside our pipe. Heat rises, right? When it gets to the top, it cools, and then it comes back down. So you have this convection current going on, and I wanted to keep, we put crystals at the top, and we were able to double those in one day, double their size. So if they're at the top, that's where coming out of solution, the crystals precipitate, and they grow on there, and they grow, and that's how we grew it. So I knew my sandstone had to do the same thing as that crystal, only I had to keep the sand in the upper part of the it's called an autoclave, but this high pressure pipe, right? So that's why I made these little pieces of pipe with the screen on each side, and we held it up there, and guess what happened? After a couple runs, we got it to where in the water, when it would rise, it came through the screen, came through those particles of sand, and crystallized next to the sand, and actually glued those pieces of sand into sandstone and made it into rock. I have some large pieces of sand from Lake Tahoe. I mean, they're large, little teeny pebbles actually of sand, very large size of sand. And when I opened up the metal that they were inside a piece of copper pipe, and I opened that up and took out the piece of sandstone, I actually put it in water, and you'll find a lot of sandstones will dissolve over a time period in water just because they weren't made under that much pressure. But because we made this under a lot of pressure, that piece of sandstone has been sitting in water for 15 years now, and it's still sandstone. It hasn't dissolved. So we made fine and coarse sandstone, and to demonstrate how this is made, and then how it's glued together with other small little crystal quartz, which glue all the larger crystals of sand that are already together.